Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Introduction to Reinforcement Learning. AI learning by trial and error. How AI learns to make decisions by trying things and getting rewards or penalties. Imagine teaching a puppy new tricks. You don't give it a manual. You show it. It tries. And if it does well, it gets a treat. Reward. If it messes up, no treat. Or a gentle no, a penalty. Reinforcement learning, RL, is exactly how AI learns this way. By trying things out, getting feedback, rewards or penalties, and figuring out the best actions to take to maximize those rewards over time. It's like AI learning from experience. Just like humans or animals do. As a developer, you're building the brain that learns from these experiences. In RL, we have two main characters. 1. The agent. This is our AI program. The learner. Think of it as the puppy or the person playing a video game. It's the one that decides what to do. 2. The environment. This is everything outside the agent. It's the world the agent interacts with, the living room for the puppy, the game world for the player. The environment gives feedback and reacts to the agent's actions. Developer's perspective. As a developer, you design the agent's brain, its decision-making logic, and set up the rules and boundaries of the environment for your AI to explore. These are the fundamental pieces of information the agent uses. State. This describes the current situation of the environment. For the puppy, it might be owner is holding a treat, puppy is sitting. For a game AI, it could be the positions of all characters on screen. Action. This is what the agent chooses to do in a given state. The puppy might stand up, lie down, or bark. The game AI might move left, jump, or shoot. Reward. This is the crucial feedback from the environment. It's a numerical value, positive or negative, that tells the agent how good or bad its last action was. A treat is a positive reward. A scolding or losing a point in a game is a negative reward. Penalty. Developer's perspective. You'll define what constitutes a state, what information your AI sees, what actions it can take, and crucially, how rewards are calculated based on its performance. RL isn't a one-off event. It's a continuous cycle. 1. Observe state. The agent looks at the current situation. The state. 2. Choose action. Based on what it has learned so far, the agent decides on an action. 3. Perform action. The agent executes the action in the environment. 4. Receive feedback. The environment reacts, provides a reward or penalty, and transitions to a new state. 5. Learn and repeat. The agent uses this reward and new state to update its understanding of what actions are good in which situations. Then starts the loop again. Developer's perspective. Your job involves coding this loop, implementing the logic for how the agent learns from the rewards, and making sure the environment provides consistent and meaningful feedback. After many trials and errors, our agent starts to form a strategy for what to do in different situations. This strategy is called its asterisk policy. Asterisk, think of it as the puppy learning. If the owner says, sit, state, I should sit, action, to get a treat, reward, single quote, asterisk, a policy is essentially a map that tells the agent, given this state, this is the action you should take. The goal of RL is to find the asterisk optimal policy, the best strategy that maximizes the total rewards the agent gets over the long run. Developer's perspective. You'll be implementing algorithms that help the agent discover and refine this policy. It's not about you explicitly programming every action for every state, but designing the learning mechanism itself. Imagine choosing between getting $10 right now or $100 a year from now. An immediate reward is clear, but sometimes an action that gives a small reward now might lead to bigger rewards later. RL agents also learn to think long-term. This long-term goodness of being in a particular state or taking a particular action is what we call value. The agent doesn't just look for immediate rewards. It learns which states are valuable, because they often lead to high future rewards, and which actions lead to those valuable states. Developer's perspective. While complex, understanding value helps you appreciate why RL agents sometimes make seemingly counterintuitive moves in the short term, but achieve impressive results over time. Algorithms like Q-learning help agents estimate these values. RL isn't just theory. It's powering some amazing applications. Game playing. AI agents that can beat world champions in chess, Deep Blue, Go, AlphaGo, and even complex video games like Dota 2 or StarCraft 2. They learn optimal strategies by playing millions of games against themselves. Robotics. Teaching robots to walk, grasp objects, or navigate complex environments by rewarding successful movements and penalizing failures. Self-driving cars. RL can help cars learn optimal driving policies, like how to merge into traffic or park, by simulating different scenarios. Personalized recommendations. Optimizing content recommendations, e.g., what movie to watch next, by learning what keeps users engaged over time. Developer's perspective. As a developer, you could be building the simulations, designing the reward functions, or integrating RL components into systems for these kinds of applications. As a developer, understanding RL opens up new possibilities. Building intelligent agents. You can create AIs that learn to solve complex problems independently, rather than being explicitly programmed for every scenario. Optimizing systems. From resource allocation to supply chain management, RL can find optimal strategies for dynamic systems. New problem-solving paradigms. It pushes you to think about problems in terms of agents, environments, and rewards, which is a powerful way to approach challenges that involve sequential decision-making. Future of AI. RL is at the cutting edge of AI research, driving breakthroughs in areas like general intelligence and complex control systems. Developer's perspective. You'll be using programming languages like Python, libraries like TensorFlow or PyTorch, and specialized frameworks to define these RL systems, run simulations, and deploy trained agents. It's a fascinating field for anyone wanting to build truly autonomous and adaptive software. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.